So we're going to solve equations with fractional exponents, and we are going to try to get this part right here. So we want this part right here on the left side of the equation. So all of this, it needs to be, put my line in on my sides of my equation, it needs to be alone. And it's not. I need to be able to move this away from it. So I either subtract 5 from both sides or I move it and write down that I've subtracted 5 from both sides. And it's not here anymore. And that's going to leave me with this part I wanted to be isolated on that side. Okay, well, this is where things can be tricky. You could do a couple of different things. One thing you could do is you could say, well, I know that I could rewrite this as the third root of 2x plus 1, this whole thing to the 1 power, equals negative 5. And then I could cubed root both sides. I'm going to change that, it didn't equal 3. And I could cube both sides to undo that cubed root. And that's one way to address it. Or I could, so we did this in a different video, so I did this exact same problem when I did solving radicals in 2 steps. Or I could do the reciprocal of the 1/3, because I know this logic right here, that I know, I'm going to do this in purple, okay, that if I have 1/3 and 3 over 1, that's going to give me 3 over 3, which is 1. And when we have a power of 1, we typically don't write it down, right? I don't say, well, I have 5, or I have 5 to the 1. We usually just write down 5. All right, so I'm going to use this concept right here. So I'm going to box this guy up. I'm going to use this concept right here. I'm going to use it, and I'm going to say that if I multiply this side by 3 over 1, and I multiply by this side by 3 over 1, then I'm going to end up with 2x plus 1 on this side, because this is just going to go to 1. And I'm going to get negative 5 to the third on this side. All right, well, since this left side is just 2x to the 2x plus 1 to the 1, I really don't need any of this. I mean, we know that anything to the 1 power is just itself. But I need to finish up the math on the right. So I'm going to say, well, that's equivalent to saying negative 5 times negative 5 times negative 5, and that's going to be negative 125. And I still have this 2x plus 1 on this side. Now I need to isolate the x, so I'm going to say, well, this guy right here, I'm going to make him, I don't know, dark green. This guy right here needs to be alone. So I need to move things to the other side, and I'm going to draw this line back in. I need everything that isn't an x to no longer be on the left. It has to be on the right. So I'm going to circle and move this 1 to this side, and that's going to be a minus 1, because when I move it, it changes signs, or what I'm really doing is subtracting 1 from both sides. And that goes away. And this is going to give me 2x equals negative 126. And when I want to get my x alone, I have to divide by 2 on both sides. So there's really a dot right here. So I'm going to divide by 2, and this is going to equal negative 63. So the thing we learned was that we could use the reciprocal. So we could use I'm going to put this in purple. We could use the reciprocal to simplify this. All right. Our next problem, again, I did the same problem in a different video. I just did it in radical form. So I'm going to write it over here very quickly and say I could do this doing my exponents, or I could rewrite it and say I have the fourth root of 4 minus t, and that's the same as the fourth root of 6. And this is really to the 1 and to the 1, but I don't really need all this stuff in here because we don't write down to the 1 on things. Okay, so I have that. And this is a way to do the problem if I wanted to. I'm not going to because I did this problem, exactly this problem, in a different video. I'm going to use this reciprocal idea, this one that I had up here where I said, hey, I can multiply by the reciprocal and it turns it into 1. And I'm going to multiply by 4 over 1 and multiply by 4 over 1. And when I do that, that makes this give me 4 minus t to the 4 over 4 and 6 to the 4 over 4. Well, 4 over 4 is just 1. So that's 4 minus t to the 1 and 6 to the 1. And we don't write down to the 1. It's not a thing. We all know that it's assumed to be to the 1 power if it's there. Now what I want to do is I want to isolate the t. So I'm going to say, well, this guy right here, whoops, let's not do that in color. Let's do it in highlighter. This guy right here is my goal. That's what I want all alone on the left side. I don't want anything else next to it. So I need to move this 4 to the other side. And if I wanted to do the opposite operation, I would minus 4 and minus 4, but I'm going to circle and move it. I'm going to move it to the other side, and I'm going to change its sign because it's the same thing as subtracting 4 from both sides. And that's going to give me negative t equals 6 minus 4 is 2. Well, the only part I want on this side is the t, and that negative has got to go. And that negative is really a negative 1. And there is no sign between the 1 and the t, and that means there's a dot there. And the way that I undo multiplication is I divide. So I'm going to divide by negative 1 and divide by negative 1, and t equals negative 2. Okay. Last one. My goal first is going to be I need to get the part where it has a radical, or not a radical, but an exponent all by itself. Because if I were to rewrite this as a radical and say this is 2 square root of y minus 7 equals 9, I would also want to get just the radical by itself on the left side with nothing else there before I started my math. I've already done this problem in another video in radical form, so I'm not going to do that one here, but that's how you would do it. That's how you'd set it up, is turn your powers into radicals. What I'm going to do right now is I'm going to isolate the part I've highlighted. So I'm going to circle and move this guy to the other side, which is the same as adding 7 to both sides. When I do that, I end up with 2y to the 1/2 equals 16. I still want to get this part alone, and the math between the 2 and the y to the 1/2 is a dot because there's no sign there. And I'm going to divide by 2 on both sides, and I get y to the 1/2 equals 8. I'm going to rewrite that. It doesn't quite look like it's a power, so to the 1/2. Okay. I'm going to use my opposite operation, or using reciprocals, to undo that 1/2. So I'm going to multiply by 2 over 1 and 2 over 1 on both sides. When I do that, I get y to the 2 over 2, and this is 8 to the 2, and y to the 2 over 2 is 1, and 8 to the 2 is 64, and I really don't need this power of 1 on this. This is my answer.